Okay, welcome to our last installment on creating the Osmosis Solitaire game. Or maybe the second to last installment. Depends on, well, we'll see. So we're going to look at Click Card. Click Card is bound to a left button click on the table. So this is the method that's responsible for selecting cards when you click on them, placing cards over in the played slot, and all of that action. It's also responsible for deciding whether or not a card is eligible to be played. So when I click on the Five of Hearts, that's not eligible to be played, and that's all taken care of inside of Click Card. Now, the issue here is that there's lots of different cases to look at, so the logic is a little bit complicated. All right, well, let's start in. Now, the first thing we do is fairly clear. When a left button is clicked on the table, then we get the position of it. Now, you might think the first thing to do is check to see if a valid position was clicked, but that's actually not what we're going to do. When you click on a card, two things get set. Card position, and card selected. Card selected is a list, and the list contains a tuple for the card. So this is the Five of Hearts, and the position of the card is in K row 2. So when we come in and we've had a click event, we actually check to see if another click event has occurred before. And if it has, then we go and get the card selected, the position of it, because that's the second entry in that list, and that position is also a tag for the rectangle that the card was at. So the tag for that rectangle is actually K row 2. So we make use of that, and we've been using these ideas a lot with these tags to put the outline back to black. So anytime we click anywhere else on the table, that outline is going to go back to black. Okay, so now we check after that to see if the position is a valid position. And there's two positions that we could click on that are invalid. First of all, if the position is none, that occurs when you click anywhere outside of one of these rectangles. Now, that doesn't get set down here for a reason. This actually gets set sort of at the end of all this code, but when you click on a none position, we actually return from clicked, so nothing happens. I mean, I suppose I could fix that, but I really don't need this information over here. It's not part of the game. As soon as I'm done doing this demo, this is going to get deleted, so I'm not going to worry too much about whether or not this is getting, position is getting set out here at none. And then the other place you can click where nothing happens is on the deck. You can't select a card from the deck that's face down to play anywhere, so that doesn't cause any action to happen when you click on it. So those two possibilities both cause us to exit immediately from the clicked method. All right, now there's two types of actions that we need to distinguish here. There is selecting a card, which then sets the card selected in a position. And then there's actually playing the card. And watch what happens when I do that. Watch what happens to card selected, to position. The kitty in the third row is going to lose that 6 of diamonds, and it's going to go into the third row of played. So when I click up here, we see that that 6 of diamonds is moved. We also see that card selected has been reset back to nothing, so there's no card selected. The highlighting is gone, and the position, however, is staying at P row 1. And I can click over here all I want, but I'm not selecting cards when I'm clicking over here. It's not until I click here or click on the stack that I'm actually selecting a card. So I think that's worth thinking about. Thinking through clearly the idea of when you click on the table, you may either be selecting a card or playing a card, and how do we know what the user is intending? And it becomes pretty clear when you think about it in terms of the position. If you're clicking on the stack, or if you're clicking on the kitty, then the user is trying to select a card, If the user's clicking over here in the played rows, they're trying to play a card. Whether they can or not is a different matter, but that's what they're attempting to do. So you'll see this broken down inside of clicked, or click card, I should say. I kept saying clicked, in terms of the if statements. So we're checking to see if the position is stack. That means that they're selecting a card. If they have selected one of the kitty rows, they're selecting a card. If they have selected one of the played rows, that means they're attempting to play the card, and the logic of this is going to be more complicated than these two. Okay, so up here, in these two cases, they are attempting to select a card. And the logic is pretty simple. First of all, the place where they're selecting it from, there has to be cards there. So if the stack length is not 0, let's do a new game. If I click on the stack right now, there's no cards there, nothing happens. And what's the reason for that is this if is failing. And so it's just dropping out and there's no operations to do. So this is only going to occur if the stack length is not 0. So let's put a card over there. And in the case that the stack length is not 0, we're going to set the list card selected, and we're going to set it to be the top card on the stack. So to get the top card on the stack, we measure the length of the stack, subtract 1 to get the index to the last card in that list, and then plug that index into the stack. And then we also append the position, which in this case is going to just be the string stack. And then we're going to outline the correct rectangle in red. So how do we know what the correct rectangle is? Well, remember, the rectangles were tagged with those positions. So we just pass in stack. I could have just typed in the string stack here and outlined that in red. Okay, so when I click here, we expect to see card selected and position to change. And there they go. So was this piece of logic right there being executed. All right, now what happens if we are in one of the kitty rows? And this is similar to what we're going to do down here with the play rows. We can tell if we are in a kitty row if the string k row appears in the position. Remember, the positions in this case would be k row 1 through k row 4, which I keep saying this over and over again, but it's worth pointing out one more time that those are the keys for this dictionary, self.deck corners. The fact that these keys, that the tags are all the same, makes things really convenient when you're writing the code. So you can use those addresses in multiple ways. Oh, and that those are also positions on the table. The fact that we're using the same thing in multiple ways makes the code really convenient to write. Okay, so if it's one of the kitty rows, this is going to be k row 1 through k row 4. We need to know which row it is. And we've done this trick before, but it's going to be the last character in the string self.position. So this gives us the last character. Convert that to an integer and subtract 1. And I think I've said this before. I'll say it again. This should be in a try except block, because converting a string to an integer can fail if this isn't a 1, for example, or a 2. So if somebody comes in and messes with the code somehow and changes these values for k row, this is going to screw up. So there's multiple ways to handle that. I'm actually of the opinion that if somebody comes in and changes the code and changes those keys to be something other than k row 1 through k row 4, the code should actually fail. They should, in that case, there may be valid reasons to change the code, but they're going to have to go through and look at the logic and see what's going on here to see whatever changes they're making, why it's affecting this. I think the error needs to occur so they can realize that, hey, they need changes down further down the road to happen, so further down the code. Anyways, no try except block. If that conversion to int fails, they've got bigger problems. This really should be a 1 through 4 here. Okay, enough said about that. So we have the row that's been selected. Then the logic now is the same as above. We measure the length of that list. So we plug in row selected into kitty to get a list of cards in that row. We check to see if the length of that is 0 or not. And then we set the card selected to be, okay, this is a long line, but it's the same idea as up here. We take the list of cards from the row in the kitty that has been selected. We take the last card in that list, and then, or the top card in that list, same thing I guess, and then the position. And then we take the position and outline that rectangle with red. Okay, so those are the two actions. Whoops, I didn't want to minimize that. What I wanted to do is over here, those are the two actions that make this clicking work. So that's the selection process. Remember that sets self.card selected. Okay, now the next possibility is we have select one of the played rows. So this means that we are attempting to play a card. There's a move card procedure in here. And I've done this a little bit differently than I did with place card. Remember that place card is actually its own method. But this move card I've put inside the method click card. And the reason why I've done that is because the only place that you will be moving a card is right here if the user has clicked on played row. So to me it made sense that this procedure could just be in here. The place card is called from multiple places. It's called from inside of click card, but it's also called from double click, and it's also called from deal. So to me, because it's called from all those different methods, it felt like place card should be its own method. Now, move card does not take any of the logic of whether or not the card should be moved or not. It just moves the card. So the assumption is when you're calling move card, you've already made a decision that you are making a valid move. All right, it accepts a from list. So this is going to be a list of cards where the card that we're moving is at. It accepts a tuple. It accepts the start position and the final position. So this is the place where the card is at, the position on a board, stack, deck, K row 1 through K row 4, and the final position in this case is actually going to be a row number, because we know in this case if we're going to a final position, it's got to be one of the played rows. So this is actually just a row 0 through 3. Okay. Oh, and it's documented, so all this stuff is up here. Okay. Now, we first get the tag. So the card tuple is one of these tuples, like this right here. This tuple's 4 of clubs. We get the tag for that card just by concatenating the first and second entry in that tuple. So suit plus rank. Then we are going to delete the card from where it is because we're actually moving it. We're going to get the address for the play row that we're going into. So we take the final position, which is here. Remember I said that was a 0 through 3. We add 1 to that, make that a string, and concatenate with P row. So this now play row is going to be one of the play row 1 through play row 4s. We're going to take that card tuple and place the card in the played row. So we've deleted it from where it was and placed it where it is. Now these, you have to remember what's going on here. This is GUI action. This is actually moving the image. That's it. But we also have some lists we have to maintain. So let's try to be clear about what's going on here. When we go to move, when I move this 2 of spades over here, a bunch of things have to happen. The image here of the 2 of spades has to be deleted, and a new image for the 2 of spades has to be created over here. Then, over here in the list that we're maintaining of all these cards, K row 1 has the 2 of spades in it. That has to be deleted off from that list and appended onto the P row 1 list. So when I make this move, all 4 of those actions have to happen. And they're separate things. There's actions going on in the GUI where we're moving images, and there's actions going on underneath in our code with lists. So right now, we have deleted the card and placed the card. That's simply GUI. Now what we need to do is change the list. So this is a list, the from list. We want to remove the card from that. So we've seen how to do that. We just pop it off. Okay, now the other thing is, and this example didn't make it clear. Watch me, here we go. So I have a spade. When I play this spade, I'm going to delete the queen here, place the queen down here, but then in terms of images, there's a card underneath this on the stack. That card needs to be placed there too. So now I'm checking to see, after I've popped this thing off from the from list, and I know there's something on the from list to pop, otherwise I wouldn't be calling move card, so that logic's already handled. Now I check to see, is there anything still left on from list? And if there is, I'm going to place that card where the card that I'm moving came from, the start position. So that's why we're passing in start position, is so that we can place the card beneath it if it needs to. Okay, so we're placing a card, and we're placing the top card in the from list here. And finally, we're going to append the card to the played list in its final position, which was that row that we passed in. Remember, this was row 0 through 3. Now, there's one more thing to point out with move card. We're passing in lists here. Those lists are mutable. That's very important because any changes I make to those lists in here occur to those lists back from where they were called. I'm going to point that out again when we actually make a call to move card, but I want to say that here, these lists, this list is mutable, and right here we're doing an append to self.played. This is a mutable list, so that is also going to affect the list back here from the calling code. Okay, so that's basically what move card does. There's 5 possible things that have to happen. Again, just a quick review. You have to delete the image of the card that's being moved. You have to replace the card image. If there was a card underneath the card being moved, you need to place that image on the board or table. And then you have to update the lists over here. All right. And now we're going to get into the logic of how the cards can be played. First of all, has there been a card selected previously? So if I go back to my board, no cards have been selected, and I'm clicking on P row, nothing happens. Now remember that this move card, when you come inside of this if, so we know that one of the played rows has been clicked on, this is not executed. It's going to skip over this. The compiler will skip over this, or translator I should say, and go right to here, and then we'll come back to this when we call move card down below. Okay, so if you think about what happens when you click on P row, this if is executed and we go immediately to this if. And this is basically saying, well, if you're going to play a card, you have to have selected one, and if you haven't, this is just going to drop out and nothing will happen. Okay, so if a card has been selected, first of all, we're going to pull out a bunch of information. We know that played row has been selected, so we're going to figure out which row in the played row was selected. And this is the standard trick. We know that it was in position. We get the last piece from that string position. The last character in that will be the row. We convert that to an int, subtract 1, and that gives us the row in the played row we wanted. Card selected is a list. That list, again, has tuple information and place information. So we're going to pull that out. What card did we select? Is card selected 0, the first item in that list, and the position of the card is the second. Now, it's a possibility that this position could be one of the kitty rows, and if it is, we want to know which row in the kitty it was. If we're taking a card from the stack, we're going to have card row be none. Otherwise, we're going to go in, if K row is in card position, we're going to figure out the row. This is the exact same code we had up here with row selected. Okay, we want the suit and rank of the card, and we'll see why we need that in a minute. So remember that the card is a tuple. The card is a tuple. We want the suit, which is the first item in that tuple, and the rank, which is the second item. So those two things. Now we'll see why we need those. Okay, now we need to separate this out a little bit. If we are playing in the first row, there are some things that we need to check. basically we need to check, are we playing the very first card of the game or not? So this checks to say we're playing in the first row. Is the length of this not 0? Which means there's already cards in the row. So if there's already cards in this row, then we need to know the suit of the card that we're trying to play. Is that the same as the suit of the cards already in the first row? So when I play this Queen of Spades, it had to be a spade the same as the first card. So I'm going to play the 7 of spades. So note this card selected has been set. Position has been set to stack. I'm going to click down here, and when I do that, card selected, the suit will be spades. The rank will be 7. The card position will be stack. And I click down here, and it moves it. And here's why it moves. Because the suit was spade, so the suit for the card selected was spade, and I look at self.played sub 0. So here's the plays. Here's the 0 row, and so that's the first. Well, okay, so here's the 0 row is this row of the played row. Then I take the first thing, I wish I hadn't clicked there. I take the first thing from that. The first thing on there is the 2 of spades. And I take the first item in that list. I'm sorry, that tuple, which is an S for spades. So the suit of the first card is self.played sub 0, 0, 0. We're going to see this trick again. So this had that 7 of spades had the right suit, and there was already cards in the row. So now we're going to go down and we are going to move the card that we were playing. In this case, it was the 7 of spades that we played, right? We're going to move that. And the only question is, are we moving from a K row, from a kitty row, or from the stack? And the only difference is between these, they get called with a card, they get called with the card position, they get called with the row selected. So what's the difference between these then? Well, the difference is that we're calling, in this case, move card with the kitty list. In this case, we call it with the stack list. Now, remember what I was saying up above. These are lists. So I'm calling this with this kitty list, and up here in move card, it's relabeled the from list. But those two labels, from list and kitty, point to the same thing. So one's an alias for the other. So any changes made up there move card are going to change the kitty. And notice that, or the stack, notice that when I make a move, so I can play this 2 of clubs. That 2 of clubs is on the stack. When I play that 2 of clubs, that's going to call that move card with this list. But because that list is mutable, any changes made to that list and move card will also be affected down here. All right, hopefully that makes sense. So now we want to look at what if the length of this row isn't 0. I'm sorry, is 0. In that case, we're playing the very first card. So if the list, I'm sorry, if there's nothing in the first row, then we must be coming or pulling the card from the first row of the kitty, right? That's the only card we can, that's the card we play first, is the one card in the first row of the kitty. So we check those two things, and if that's the case, we go ahead and move the card from the first row of the kitty into the first row of the play row. And the other thing we do there is, new game, remember we had this message here? When we play that first card, we delete it. So that's where that first message gets deleted. All right, now what happens if we're playing in one of the other rows, row 2 through 4? So again, we check to see, is there anything here or not? Oh, I'm sorry, no. We check the previous row. The previous row has to have something in it for us to play. Now, we wouldn't quite have to check this. We could look to see if our card is actually in the other row. But to do that, we have to know the suit of the previous row. and I'm getting the suit from the previous row just like I did above by indexing the first card in the row and the first item in the tuple for that card. But when you do this index right here, you're assuming that there are things in this list. If you put this index into this list and there's nothing there, your program's going to throw an error. So this if here is actually here to make sure that this won't throw an error. Okay, so now I'm going to get the suit of the card above. So we have the row selected. This is the row above. This is the first card in the row above. This is the suit. So now that I have that suit, I'm going to check to see, is there anything in the row. So I'm going to set, let me back up a little bit. We have the suit for the card above. I'm going to set now the suit of the row that we're trying to play in. And I'm looking at two different cases. If there's already cards in that row, then that's this case right here. There's already cards in that row that's been selected, so the length of that list is positive. Then the suit of this row is the same thing we've been doing before. First card in that row, first item in that tuple. If there are not any cards already in that row, then I'm just going to set the suit of this row to the suit of the card that I'm playing. That's going to be the new suit for this row. There is one more check we have to do to make sure we can play that card, but we're going to do that down below. Okay, if neither of these conditions are met, then this card is not going to be able to be played. So we set card selected back to an empty list and return. So let's go up here and look. If I want to play the 2 of hearts here, that's no good. So that's that execution right there. Execution is kind of an interesting choice of words. Nothing happens. Okay, now after all this, so we've set the suit for the current row. We're going to check to see, is the suit of our card the same as the suit of this row? And if it's the first card in the row, it automatically is because we just set it to be that up above. So is the suit of this card equal to the suit of the first card in the row? So if I try to play the 2 of hearts up here, that fails. And it says, no, it's not. In fact, you can't do that. So this fails right there. But if I try to play the 2 of clubs, it says, oh yeah, that's the same suit. We can go ahead and play that card. And here's the other thing. To play a card down here, that card has to already be up there. So if I had the 7 of hearts here, I could play the 2 of hearts because the 2 of clubs is up here. Here's where we're going to make that check. We take the suit from above, so the suit of the row above the card we're trying to play, the rank of our current card, and put those two things together. That card should be, so this is a card now, this is a tuple. That card should be in the row above. All right, now do I want to take the time to go through and see if we can find a 7 of hearts? Yeah, I can play an ace. Oh, look at that, 7 of hearts. So when I'm going to go to play the 2 of hearts, so the card selected is a 2 of hearts. It's in kitty row 3. When I click here in this row, the suit above is going to be clubs. The rank of the current card is going to be a 2. And so this right here, well, let's arrow this down a little bit. So suit above will be club, rank will be 2, and we're asking is club 2 in the previous row. Well, let's go look. In the previous row, we have right there the 2 of clubs. So this will pass, and I'm able to play the 2 of hearts up in this row. So hopefully that makes sense. And if that's the case, then we go ahead and play that card. This is the same code we had before. If you're coming from a kitty row, then we're going to pass in the list from the kitty that we're playing out of, and otherwise if we're playing from the stack, we're going to pass in the stack as the list we're playing the card from, and then we're done. So those are all the possibilities. The last thing we are going to check before we get out of this is the whole reason we actually keep track of the played list. We don't need this other than the fact that when all the cards have been played, the sums of the links of those 4 lists will be 52, and you can print out "you win." If that doesn't happen, that means that we have played a card or not. We've tried to play a card. We set the card selected back to empty, and off we go. And then there's self.set list. Again, that is the little procedure that sets this stuff over here. I think I might make a separate video on how to do that. If you're interested in watching it, you can. But this is the end of the Osmosis Solitaire game. Oh, except for one thing. So down here we call "you win." "You win" just makes a big message. So we get a font family, make it size 100, weight it bold, put it right in the middle of the table. So we take the table width and table height, divide them by 2, put them in the middle of the table with that 100 point font, U1 in bold, and we even color it red. So there you go, Osmosis Solitaire. So right after I said in my lesson video that it was really hard to win this game and I wasn't going to be able to win one to show you the U1 tag, I won one. So there you go. It prints out U1 in the middle of the board. Exciting stuff.